Hey everyone, welcome to Pre-algebra, Chapter 9, and we're going to be talking about real numbers and right triangles. But today, before we get into all of that, we are on, of course, Section 9.1, and we're going to be talking about square roots. Alright, so there you go. That's a square root, correct? Not really. Actually, this is rectangular, so we couldn't even call it a square. It is a root. It looks pretty cool, but it's not a square root. Of course, we're talking about symbols that look like that. Now, we call it a square root symbol, but more specifically, this guy is going to be called the radical symbol. And inside, we will, most of the times have a number, sometimes a variable, but either way, it's called the radicand. Okay, so radical, radicand, and what I have to help you remember is this. If you remember Teenage Mutant Ninja Turtles, I actually think they're making a movie coming out soon, maybe this fall or something like that. They are radical, right? They always say radical dude or something like that. Maybe it's just one of them. I don't remember. Anyway, so I gave you a little radical symbol made up of the Teenage Mutant Ninja Turtle game pictures, and inside I have what? Candy, right? So radicand. So radical, turtles, radicand, candy. Alright, we can call that whole thing item number 1, and now we'll move down to item number 2. Okay, what is the square root? Well, when you ask that question, you need to really be asking, what is the square root of something? Okay, so it would be more accurate to ask you, what is the square root of 4? What is the square root of 16? Okay, that's really how we want to talk about that thing, because different numbers are going to have different square roots. Okay, so if I said, what is the square root of 16 right here, what would you say? Well, you probably remember that, you know what, I know 4 times 4 is 16. Okay, so what is the square root of 16? Well, it's 4. All right. Now, what does that look like? Well, if someone asked you, what is the square root of 16, they'd probably give you that. Okay? And they would say, that would read, what is the square root of 16? And we would evaluate that expression there. And again, this is a radical expression because there's a radical symbol. And I'd say, well, let's see, what number times itself gets me 16? Well, 4, right? But that's kind of a complicated answer. And the wording I gave you is kind of what makes it complicated. So let me explain. We would read this as the square root of 16, right? But technically, that reads, what is the positive square root of 16? Okay. Or you could think of it as, I'll just do this in typing a little faster. What positive number, when multiplied by itself, gets you a product of 16. Okay. So saying both of these are the same. This is the same as this, all right? Now, why do I say what positive number when you multiply by itself gets you 16? This isn't that complicated, right? It just says, what's the square root of 16? Well, it's 4. 4 times 4 is 16. Well, that is true. But keep in mind that negative 4 times negative 4, well, negative times a negative also is a positive, and it's also positive 16. Okay? So let me explain this a little further. When you see something like that, what that means is what positive number, when multiplied by itself, gets you 100. And we would say positive 10 times positive 10 is 100. So 10 is the positive square root of 100. But what if I gave you this? What does that mean? Well, that actually says what negative number, when multiplied by itself, gets me 36. Well, I know that negative 6 times negative 6, negative times a negative is a positive, so it would be positive 36. So we would say the answer to that is negative 6. This is the negative number when multiplied by itself gets me to 36. Okay? So what if you encountered something like, that? What would you say? Well, we know the positive root is going to be positive. We know the negative root is going to be negative. So what is plus with a minus under it? That means tell me both the positive and negative square root of 25. And so our answer would be, well, let's take care of the positive first. I know positive 5 times positive 5 is 25, right? But I also know that negative 5 times negative 5 is also 25. All right, so I want you to take a minute, pause the video. I want you to try these 3 problems. Play it when you're done, see how you do. All right, so the directions say evaluate the expressions, right? So here we have an expression, and it's a radical expression because we have a radical symbol there. And it asks us, what is the negative square root of 49? Otherwise known as, what negative number times itself gets me positive 49? Well, I know that negative 7 times negative 7 equals positive 49. So what's our answer? Negative 7. Down here, what's it asking? Well, there's no sign there. But when there's no sign there, we assume that it's positive. So this is asking us, what's the positive square root of 81? If you really wanted to, you could draw in a little positive sign there just to kind of remind yourself. What positive number times itself gets 81? Well, 9 times 9 is 81. So what's our answer? 9. And then lastly, number 5, all right, plus or minus the square root of 4. What is it asking? What positive number and what negative number times themselves get positive 4. Well, positive 2 times positive 2 equals 4. But negative 2 times negative 2 also equals positive 4. So what's our answer? It's both 2 and negative 2. All right, so now let's talk about perfect squares. Well, what is a perfect square? Well, it's a number that is the square of an integer. So what does that mean, the number that is the square of an integer? Well, actually, everything we've been dealing with thus far in the video, all those numbers have been perfect squares. Because I would say that 100 is a perfect square. And why? Because there's an integer out there that I can take times itself to get 100, and that would be 10, right? 10 squared equals 100. So we say 100 is a perfect square because there's a number that I can square to get to 100, right? We could also say that negative 10 squared is 100 as well. So why don't you take a minute, I want you to think of 2 other perfect squares. All right, so 1 is a perfect square. Why is that? Well, think about it. 1 squared equals 1. 4 is a perfect square. Why? Oh, and I'm sorry here, negative 1 squared is also 1. 4 is a perfect square. Why is 4 a perfect square? Because you can take 2 and square it to get to 4. You can also take negative 2 and square it, which would be negative 2 times negative 2, which would also equal positive 4. So those are all perfect squares. Well, if we have perfect squares, then we're probably also going to have imperfect squares, right? Something that is not perfect. So if a perfect square is a number that you can it can be reached by multiplying some other number times itself, okay, such as 16 is a perfect square because 4 squared, 4 times 4 equals 16. What about 17? Well, this guy's perfect. 16 is perfect, but 17, is there any number out there you can multiply by itself to get you to 17? Any integer, so a positive or negative non-decimal number? No, right? And there's no number out there times itself that gets you exactly to 17. So what we would say is 17 is an imperfect square. Okay, that's the type. But what if someone, or what if you saw a problem that said that? Okay, what would you do? Well, if they said leave your answer in square root form, guess what? Your answer would be the very question they gave you, okay? But what if they said, find the square root of 17, and again, we're talking about the positive square root here, because there's no sign right there, there's no negative sign there. They said, leave it, or round to the nearest hundredth, what would you do? Well, you'd take your calculator out, and you'd hit second, and then the x squared button, and so what you should see on your calculator now is that. And then, next, you're going to enter in 17. And then you're going to end your parentheses, and you're going to enter. And what do you get? Well, when I do that, I get 4.123105626. Okay, if they say round to the nearest, let's say 10th. No, let's do 100th, right? We want to round to that place right there, and that looks like a 7, but it's actually a 2. So I look to the number to the right and say, oh, do I round up or keep the 2? Well, it's a 3. It's not 5 or greater, so I keep the 2. So my answer is really 4.12. And I'd say approximately, squiggly equals means approximately, 4.12. All right, so take a minute and work on those two. You're going to approximate the square root of both those numbers to the nearest thousandth. All right, so when I take the square root of 23, what I get is 4.79583. Keeps on going. Nearest thousandth, so it's a ones, or a tenths, hundredths, thousandths. So right there. So we get 4.795 gets rounded up because that guy is an 8, so 4.796. And then over here, well, what does this mean? Well, remember, it means what negative number times itself gets me to 3. Well, we know that there's no number out there that is an integer, okay, otherwise known as a positive or negative non-decimal number, that you can multiply by itself to get you to 3. Okay, but if I take the square root of 3 in my calculator, what I get is 1.73205, so on and so forth. We're rounding to the nearest thousandth, so that place. So what's to the right? Well, it's a 0, so that 2 is just going to stay a 2. So 1.732. But they're asking me for the negative root. So it's a negative 1.732, approximately. Now what I want you to do in your calculator is I want you to type this in. I want you to type in parentheses, negative 1.732, end parentheses, times, start another parentheses, negative 1.732, end parentheses, and do that. Okay, so multiply those together and see what you get. All right, so when I do that, what I get is a positive 2.999824. And we know that is pretty darn close to 3, right? But it's not quite. Okay, and that's why we call it an imperfect square. 23 is an imperfect square. 3 is an imperfect square. All right, so we're going to evaluate a radical expression, which we've already really done, but now we're going to mix it up a little bit. Okay, so I'm going to have an expression with some operations in it, such as, let's say we had 2 square root 4 plus 12. So what does this ask? Well, when you have, if I had a 2 parentheses 3, what would you tell me? Well, you tell me that means 2 times 3. So when I have a 2 square root, or radical, 4 plus 12, what that means is 2 times, you can put in a little multiplication symbol there if you want, 2 times the square root of 4 plus 12. Okay, so what do I do first here? Well, what I want you to think about is that a radical symbol is kind of like it's a grouping symbol, okay? And we know in the order of operations, grouping symbols comes first, okay? Remember that's parentheses, brackets, fraction bar. We'll actually say that a radical symbol works the same. So what that means is I need to do what's inside there. So I'm taking 2 times the square root of 4 plus 12. Well, 4 plus 12 is 16. All right, so the next step is, can I simplify inside there any further? Well, actually I can, and why? Because I know what the square root of 16 is, don't I? It's 4. 4 times 4 is 16. So I'm going to rewrite this as 2 times, what is the square root of 16? 4. And my last step is, well, hey, what's 2 times 4? 8. And there's your answer. All right, so I want you to try this one, item number 11 here, and we'll do the square root of 9 times 2 squared. Take a minute, work on that, see what you get. Play the video when you're done. All right, so I need to think of radical symbol as a grouping symbol, so I need to do what's inside there first. Well, what's on the inside? Well, I got 9 times 2 squared. All right, so I have both multiplication and exponents. So what comes first in order of operations, multiplication or exponents? Well, exponents, right? So we're going to rewrite this as 9 times, what is 2 squared? Well, it's 4. All right, now what do I have left to do? Well, got to do what's on the inside, right? 9 times 4 is 36. And what is the square root of 36? Well, what number times itself gets you 36? It'd be 6. And again, we're talking about positive 6. There's no symbol out here, so we're assuming it's always been the positive square root, and we end up with a positive 6. All right, so lastly, we're going to move on to solving equations that involve radicals. Okay, so that would look something like this. Now you might say to yourself, there's no radical symbol there, Mr. Screwbar. So you're wrong. Well, you're wrong. Sorry, I don't mean to be mean. I don't mean that. Here's what I mean. What does this read? Well, it reads as what number times itself equals 9. All right, we'd say 3. But we remember now that 3 times 3 does equal 9. But also that negative 3 times negative 3 also equals 9. Okay? So the question is, how do I actually solve this algebraically? Well, algebraically, we know when we solve an equation, we want the variable by itself. Okay, I want x to equal something, and then going to have an answer, right? So what do? Well, here's why we involve radicals. I want to get that squared out of there, and the only way to do that is to put a radical symbol over that term, and really over the whole side there. But if I put a radical symbol over that side, I must put a radical symbol over the other side. And so this actually ends up canceling. A radical, or a square root, I should say, a square root cancels a squared. And so really I'm just left with x. And now I'm partway to my answer. But what does this say? Well, you might be saying, well, it says what's the positive square root of 9, and that's 3. Which we said up there, 3. Hey, so what about this negative 3 though? Well, when you solve equations involving radicals, you're going to have two answers. Okay, when you're involving square roots, you're going to have a positive and a negative. We know from the very beginning that it says what number times itself equals 9, and we know that 3 works, and so does negative 3. So when you put a radical symbol over a number in an equation, I encourage you to do this. Give yourself the little positive or negative symbol to remind you that this is going to be both 3 and negative 3. And we can check our work by just plugging it into the original. The original was x squared equals 9. If I put a 3 in place of x and square it, let's see if that gives me a true statement. 3 times 3 is 9, and 9 is 9, so that works. How about negative 3 though? X squared equals 9. Put in a negative 3 where x was and square that whole thing. So that says negative 3 times negative 3, that is positive 9, and equals positive 9. That one also works, and you're done. All right, guys, that is all I have for you. Look forward to seeing you in class and talking more about radicals.